Good morning, my YouTube viewers. It is Crystal here, and I'm just here this morning because I wanted to do a code review. I wanted to do a code review on the HR Analytics dataset. I got the dataset off of GitHub, but there's also HR Analytics dataset on the Analytics VidHaya website. And so if you want to do this machine learning project and you don't want to use a dataset off of GitHub, then you can always go to Analytics VidHaya and get the dataset off of Analytics VidHaya because it is a competition question. And basically, I'm doing this because it was the AI project from Untitled Chapter, but I did the best job that I could, but I'm a little bit disappointed because in Untitled Chapter, basically I was taking a natural language processing course, and so this AI project doesn't have anything to do with natural language processing except for ordinal encoding the objects. And so I did it, but I'm still disappointed, and I'm going to do a blog post on this 5-hour video that I'm working on, and I'm going to say that I'm disappointed because I would have thought that if it was a natural language processing course or a video, then the AI project that I would be given to do would relate to natural language processing, because that's what I wanted to do. I wanted to improve my skills on natural language processing. So without further ado, I'm going to go ahead and do the code review of the AI project from Untitled Chapter. It was a good AI project, but it didn't have anything to do with natural language processing, and that's what I wanted to learn. I wanted to learn more about it. So we've got this data set that I took off of GitHub. And we're going to go ahead and go through that. So the first thing that we do is we go through a problem statement. I just really paraphrase the problem statement. And this problem statement says, a major company needs help in determining who to promote. Of course, the problem statement they gave was a lot more in-depth than that, but that's just, just decided to cut it to the chase. And then what we want to do is we're going to import some of the libraries that we're going to need to carry out this AI project. And we're going to start out with Pandas, NumPy, Matplotlib, and Seaborn. So Pandas is used to create and maintain data frames. NumPy is used to carry out mathematical computations and create NumPy arrays. Matplotlib is to make graphs, and Seaborn is a more highly powered graphical library than Matplotlib, and I believe that Seaborn is made on the back of Matplotlib, but Seaborn allows you to do statistics, whereas Matplotlib it can't really do that. So after we've imported our data sets, we're going to load the data sets. So we're going to use Pandas to read the data set in, and we're going to make a train and a test data set. So we've got the train data set. So the train data set has 14 columns of data, 54,808 rows of data. And so you've got the columns: employee ID, department, region, education, gender, recruitment channel, number of trainings, age, previous year rating, length of service, KPIs met, awards won, average training score, and is promoted. And then you've got the test data set, which has the same format as the trained data set, except that it doesn't have the is promoted column. And the reason for that is because we're going to have to predict on that. So we're going to check for any null values. You can see that for train. On the train set, we're going to check for any null values, and you can see that the education is left blank and the previous year rating is left blank. So what I decided to do in the train set was to actually delete all the null values. So all the null values in the train set were deleted with train equals train.dropNA. And then I decided I'm going to remove the duplicate rows in the trained data set as well, but there were not any duplicate rows. Now we're going to check for null values in the test data set. So the education and the previous year rating were not filled in some of the rows. You cannot delete those rows because that's what we're going to be submitting our predictions to. So what we have to do is we have to impute those rows. So what I decided to do was, if it was an object column, you're just going to fill the empty cell with not listed. I decided I wasn't going to make it the most commonly used cell because we don't know what it is, and it's better just to say not listed. And if it was an integer row, I decided I was just going to fill it with 0. I mean, if I had wanted to, I could have filled it with mean and then converted it to an integer, but I just decided to make it a 0 because that's what they did in the AI project. So now you can see the test where we filled in the missing values. Now we check to see if we have any more null values in test, and no, we don't have any more null values in test. So now what we're going to do is we're going to analyze the target. So target is train is promoted column. We did a graph of that, and you can see that there were a lot more people who didn't get promoted than there were who did. And so now you can see that we have a class imbalance. So in theory, that would need to be corrected for us. Well, then what you could do is you could use SMOTE to correct for the class imbalance, but I decided just to leave it as it is because in a lot of the models, they have a section where you can do balance, where they'll try to balance it. And so I just decided to leave it the way it was for the time being. But you could do, in order to correct for a class imbalance, you could use something called SMOTE, or like you could use oversampling, or you could use undersampling to try to correct for that. But I didn't do it on this occasion, but you could do it if you wanted to. And then what I did was I did a box plot. So you can see most of the values are in 0 and a few of the values are in 1. So now we're checking to see you had 44,428 in 0 and 4232 in 1. And the percentage, you had 91% zeros and 9% ones. So I did this plot. I thought it was a really beautiful plot. This is one of my favorite graphs. And you can see that we've got lots and lots of zeros with just a few ones in there. Here's another plot. This is what we were shown how to use in the AI project, and I've never used it, but this is another little diagram that you can use if you want to know more about how the different categories relate to each other. So here, we'll take here gender. So you've got male and female. So you've got more males than you have females. What a surprise. And then you've got previous year rating. And it's really interesting if you are into analytics and you want to analyze where all of the features fit into is promoted, then it's a good thing to do. I mean, obviously this was the first time that I have used this particular Plotly. So obviously I need to get a little bit more experience in that. Perhaps I could do Plotly on the Titanic dataset and see, because the Titanic dataset has less columns and less examples, and so maybe I could learn a little bit more how to use it using Titanic. But it's there, and you've got the code. The code is right here if you want to try it out yourself and see how it works. Now what we're going to do is we're going to combine the train and the test sets. So we have to drop the is promoted and then append the test to make a data frame called combi. And so you can see the two data sets are combined. Test is appended to train. So you can analyze combi and you can see that what type of features you have. You've got integers, objects, and floats. So now we're going to describe combi, and the describe only describes the numeric columns. But if you had wanted, I think if you in the brackets, inside the brackets, if you had said like all, then it would describe even the object columns. But I didn't want to describe the object columns. I just wanted to describe the numeric columns. So this gives you a few of the statistics for each numerical column. And so what we're going to do here is we're going to check the highest frequency of a value, the lowest frequency of a value, and the unique value. So we're going to be checking the department. The highest frequency value is sales and marketing. The lowest frequency value is legal. And the unique value they give you are sales and marketing, operations, technology, analytics, R&D, procurement, finance, HR, and legal. And then so it goes through each column and gives you all of that information. So if you wanted to know what each column had, then that will tell you all of the unique values. So now what we're going to do is we're going to take the age and we're going to put the age in bins. So combi age with a capital A equals PD cut X equals combi age, bins equals -1, 25, 45, 60, and the labels are junior, middle, senior. And so most of them are going to be middle. So we're going to check to see if we have any null values, because when you're working with bins, sometimes you can get some null values in there. So that's why you check to see if you've got any null values to correct it if you do. So now we're checking the displot on the age, and you can see with the age, with a little a, you can see most of the workers were from their late 20s, were in their 30s, and before their 30s they started to build up in their 20s, and it came to a peak in their 30s, and then from their 30s it started to go downhill, and there's not many people working at age 60, but hey ho, some of us have to work. Like me, I have to work because I'm divorced, so I don't have the luxury of retiring, which is why I make these videos and blog posts and courses, because I have to create content to try to get some income when I can't work anymore. So the next thing that we're going to do is we're going to check age with a capital A disk plot, and you can see most of the people fell in the middle range. A few of the people fell in the senior range, and even less people fell in the junior range. So we're going to drop the age with a little a because we don't need that anymore. Now what we're going to do is we're going to ordinal encode all of the objects. But I think, let me come back here and show you something. Okay, see, what we had to do is when we created the bins would create the age with a capital A as a categorical column, and when you try to ordinal encode it, the ordinal encoder won't encode a categorical column. And then in addition to that, when you try to make predictions, the model won't predict on categorical data. So what you have to do is you have to take that categorical column and you have to convert it to an object. And the way that you convert it to the object is right here, combi age equals combi age as top string. And that converts your categorical column to an object column because it needs to be an object column when you're going to ordinal encode it. So now we've got the ordinal encoder, and what I could have done if it had been just a few columns with a few tiny bits of data, I could have set up a dictionary to replace all of the strings with numbers, but because we had quite a few columns with quite a lot of categories or quite a lot of values, I decided that for simplicity that I would use the ordinal encoder, but I don't always use the ordinal encoder like male and female. If I had wanted to, I could have just replaced the male with 1 and the female with 2 if I had wanted to. But then I thought about it, and then I decided that, I've got lots of columns here and lots of data, I'll just put it through an ordinal encoder. So what I did was I did a for loop for call and copy. If combi call dtype equals object, combi call inc dot bit transform, combi call values reshape -1 1, and then your combi. And so what that did was every column that was an object column is going to be ordinal encoded, and that's why the ordinal encoder won't encode categorical columns, and that's why I had to convert the age column to an object column just to get it to go through the categorical column, get it to go through the ordinal encoder. So now what we're going to do is we're going to drop the employee ID because we don't need it. And so we're going to check for any null values. We don't have any null values. I made a heat map, so if you want to see how all of the different features depend on each other, how they're related to each other, then you can do that with the heat map, and the heat map will give you that information. So we got our correlation, so you can see numerically how the different columns are correlated with each other, if that's what you're interested in. If you are really into analysis, then you can see the correlation. Now what we've done here in this bit of code here, we remove columns with a high correlation of greater than or equal to 90%, but in this particular data set there were no columns that had a high correlation, so no columns were deleted. Now what we did here is we normalized the data. We take all of the data and we convert it to a value between 0 and 1, and the formula that I put in here will take all the data and convert it to 0 and 1. So now after we have pre-processed the data, processed all the data. The data is ready to be predicted upon. So we have to define our X and our Y values. Your X is your independent value and your Y is your dependent value. Y is your target. So X equals COM-B up to the length of train. So that's the equivalent of your train set. And X test is COM-B from the length of train to the end. And so that's your test set. Now what we're going to do is we're going to use sklearn's train test split to split the train set and X and Y into training and validation sets. And the reason for that is because you cannot make predictions on the same data that you have trained. And because of that, you have to take the X and the Y variable and you have to split it into two. So in this instance, our X and Y, our train and our training set is 90% and the testing set or validation set is 10%. So you can see that. Now we've defined our model. I decided to use XGB classifier. I experimented with quite a few models, and in this case I decided to use XGB classifier. I did actually get the parameters from the video that I was watching, because what I need to do is I need to learn how to set the parameters in XGB classifier, and that would be a good project for me to do. I've got lots of projects. And I got 95% accuracy using XGB classifier, predicted on the validation set, and I got approximately 93% accuracy. I used the confusion matrix, and so you can see which ones were incorrect. So you got 4330 positive, and then 127 of that was incorrect. And on 185 positive and 224 was incorrect. So that's just telling you which classifications you got correct and which you got incorrect. So it would be great if we had 100%, but we didn't. So now what we do is we predict on our test set. Predictions equals model.predict x test predictions. And now what we're going to do is we're going to prepare our submission. So what I had to do is I didn't have a submission file. So I said submission equals pd.dataframe. Submission employee ID equals test employee ID. Submission is promoted equals predictions. And then I take submission, I convert it to a CSV file, and then I read the CSV file, and so you can see this is all of the predictions. So most of them are going to be 0, and some of them are going to be 1. And what I did was I went into the Analytics VidHire website, and because this data set can be found on the Analytics VidHire website, and I put it into the website and I got 49% accuracy, which isn't too bad, because if you go into the leaderboard, the highest accuracy was 54%. So you may think, oh, 49%, that's just terrible. But if the highest one was 54%, then it's not a bad accuracy. So I'm going to go ahead and conclude this code review, because I've been talking for 24 minutes so far. I hope you got something out of it. If you've never done HR Analytics Dataset before, then at least you know how to do it. Thank you so much for subscribing to my channel and supporting me. If you like this video, please like, subscribe, and share. And thank you for watching my video, and I look forward to making more videos for you in the future.